Assalamualaikum. My name is Fairusham. I'm a student from Dr. Fairusham class. Okay, today I will be presenting about turbine flow meters. This is an example of the experiment we have in the lab too. This is the turbine flow meter. As you can see, turbine flow meters consist of three primary components. The turbine wheel, the turbine wheel sensor, the pipe fitting, and the display controller. As you can see, this is the in front of the machine. Okay, this is the display or controller. When we collect the data will display it here. Okay, the turbine wheel sensor consists of a freely rotating wheel which embedded magnet which is perpendicular to the flow and will rotate when inserted in the following medium. As the magnets in the blade spins past the sensor in the turbine wheel, the meter generates an frequency and voltage signal which is proportional to the flow rate. Okay, as you can see, the faster the flow, the higher the frequency and the voltage output that we can get. Okay, now I will be explaining about the pickup sensor. Okay, the turbine flow meters use a variety of pickup transducers to convert the rotational energy speed of the turbine wheel to a measurable electrical signal. A sensor records the produced voltage power. Okay, as you can see that the transducer is located here under the sensor. The sensor is the transducer that will convert the rotational energy speed. Okay. This transducer then transmits a proportional output signal to external readout displays or other interfacing electronic data acquisition equipment. Okay, the pickup contains a bar magnet wrapped in a sensing coil. Okay, as you can see that the sensing coil is under the sensor. This is where it collects the data when the turbine is rotating. Okay, as the rotating turbine blades pass the base of the transducer, an AC signal is generated. The frequency of the signal is proportional to the velocity of the following media. The magnetic inductive sensing method features magnetic pins inserted in the turbine rotor blade. As you can see that on each blade of the turbine, there is a pin inserted into the blade so that the coil can detect, the sensor and the coil can detect the rotational of the blade by the pin when the blade is rotating. Okay, the transducer contains a simple sensor coil and core, and an electrical pulse is induced in the coil as each blade passes the base of the transducer coil. The modulating carrier RF pickup uses a high frequency signal that is amplitude modulated by each passing turbine rotor blade. The Hall effect sensing method uses a micromagnetic pins embedded in each of the turbine blades. The Hall effect sensors interacts with each of the high flux magnets located in each of the passing blades, inducing a separate Hall effect voltage across the sensor outlet. Okay, thank you very much for this presentation.
Assalamualaikum and good evening. My name is Mohd and my matric number is MH10039. I represent my group to explain about the sensitivity of flow meter sensor. There are many types of flow meter sensor in this world. My group was explain about pedal wheel flow meter. The flow meter, firstly the flow meter is ranged by 0.1 to 60 GPM. GPM is meant by gallon per minute. Besides, this sensor also convert physical quantities into electrical quantity. The electrical quantity is proportionally commonly as sensitivity. Its units normally in terms of watt per auxiliary units. This sensitivity is for the sensor is 100 millivolt per minute. This means by 100 millivolt per 1 minute.
Selamat Ismail. I am from class Dr. Fairusham. I will present you about centrifugal pump. This experiment will consist flow turbine sensor. Now I will explain the operating system of centrifugal pump and how the flow meter turbine sensor operates. This experiment I will show and I will explain using a simulation, the flow meter, and for this mission.
We continue turbine meter simulation. This is a turbine meter. This is two-blade helical rotor and it is constructed by titanium material. Rotor made titanium, lightweight, excellent corrosion resistant. We can see the blue arrow show us the flow strain in the tube. By the way, the rotor rotates on the fixed shaft. The rotational speed of the rotor is directly proportional to the axial flow velocity of the fluid. As it is conventional turbine meter, its pickup coil is located directly above the rotor and is completely isolated in the fluid. As each plate passes under the pickup coil, the passing magnetic field is seen as the sinusoidal wave. Then the sinusoidal wave is then converted by the free amplifier into a square wave pulse stream as shown.
Warahmatullahi wabarakatuh. My name is Ahmad and my match number is MH10035. Today I would like to describe another application of the sensor industry. So I get two applications of the sensor. The first one is ultrasonic flow meter used in pharmaceutical industry. Pharmaceutical industry requires the sterility and hygiene strictly, employs advanced ultrasonic transit to technology to measure flow rate and flow velocity by clamping transducer outside of pipelines and can be measured ultra pure water tightly. For the second is the signal thermal mass flow meters. So this sensor is used usually used in oil and gas industry. So it reduce energy cost in industry, increase productivity, reduce energy costs, and maximize product yield. It also monitor natural gas on the main gas entering the plant. It's easy install and provide direct mass flow reading of instantaneous flow rate as well as catalyzed flow. Another application of the sensor industry that I get is 4 types. The first one is diesel flow meter that measure fuel usage in boilers. 2 is the water glycol flow meter application. 3 is the water supply flow meter application, drinking water utility. And the 4th is the pharmaceutical flow meter application for batching. That's all.